Hey everyone, and welcome. Have you ever stopped to think about how our digital world actually works? You know, how these massive oceans of data get from a server somewhere to your screen in like a split second? Well, today we're going to connect those dots between our apps, the web, and the giant databases that are the brains behind it all. So let's start with a really basic question that's actually pretty complicated. Think about it. You open an app on your phone. How in the world does it pull up your specific profile, your playlists, your photos from a server that could be thousands of miles away? How does that connection even happen? Well, it all boils down to this one core problem. The apps on your phone and the databases that store all the information, they just don't speak the same language. They're built in totally different ways. And this communication gap is the fundamental challenge that all of this technology we're about to talk about was built to solve. So to fix this language problem, the pioneers of computing had to build bridges. You can think of these first technologies as the original digital universal translators that allowed all these different systems to finally start talking to each other.
And the key to this whole thing was a concept called the Application Programming Interface, or API. Now, the best way to think about an API is like a waiter at a restaurant, right? You don't need to know how the kitchen works. You just look at the menu, that's the API, and you tell the waiter what you want. Waiter then goes to the kitchen and brings back your food, which is the data. It's just a standard set of rules for asking for things.
So let's look at two of the OGs in this space, ODBC and JDBC. Now, ODBC, which stands for Open Database Connectivity, was this really ambitious project by Microsoft to create one standard, one menu that any app could use to talk to pretty much any database out there. And then you have JDBC, which is Java Database Connectivity. This one was built specifically for the Java programming language, which had that whole write once, run anywhere philosophy. Both were basically these crucial translators for their time.
So what did these APIs actually do? Well, they were that universal translator. They gave developers a standard way to ask a database for info, and they hid all the messy, complex details of how each specific database actually worked under the hood. And this was a total game changer. It meant a programmer could write their application code one time, and it could connect to all sorts of different databases, Oracle, SQL Server, you name it, with just minor changes.
But, just as developers were getting the hang of this, a whole new platform exploded onto the scene and changed everything, the World Wide Web. And oh boy, did it bring a brand new and very tricky problem along with it. You'll hear this phrase a lot, and it's one of the most critical concepts to grasp about the internet. At its core, the web is a stateless system. But what on earth does that actually mean?
It means that every time you click on a link or load a new page, the web server that sends you that page completely forgets who you are. It has zero memory of what you did just a second ago. This analogy here is perfect. It's literally like having a conversation with someone who has no short-term memory. Every single thing you say is like starting a brand new conversation from scratch.
So you can immediately see why this is a massive problem for something like online shopping, right? If you put an item in your cart and click to the next page, the server would just forget it was ever there. So the solution was to invent a whole new layer of software, the web application server. These servers became the memory that the web was missing. They keep track of your state, who you are, what's in your cart, and they manage all the talking back and forth with the database. Okay, so we've got apps talking to databases and web servers remembering who we are. But as businesses started trying to connect and do business online, they ran into another problem. They needed a common language, a lingua franca, for the data itself.
And that common language became XML. Extensible Markup Language. XML was this brilliant way to structure and send information in a format that both people and computers could easily understand. Think of it like a universal ship-in label for data. Instead of just sending the number 1999, you'd wrap it in little descriptive tags, like price, 1999 price, so the receiving computer knew exactly what that number meant.
But wait a minute. That brings up another really important question, right? If my system sends your system an XML file with a tag called price, how does your system know what that means? Is it the price per item? The total price? The price with tax? For this to work, everyone needed a shared rulebook.
The first version of that rulebook was called the DTD, or Document Type Definition. It was pretty basic. It just defined what the tags could be called and how they were structured. But pretty soon, we got something way better, XSS, or XML Schema Definition. XSS is the smarter rulebook. It's much more powerful. It can enforce really strict rules, like saying a price tag must contain a number with 2 decimal places, or that a date tag has to be in a valid format. This brought some serious order to the chaos of online data exchange.
And that brings us all the way to today, to the modern frontier of where our data lives and how we connect to it, the cloud. The rise of cloud computing has completely upended the old way of doing things.
So what exactly is the cloud? Honestly, the best way to think about it is like switching from owning your own car to using a ride-sharing service. Instead of buying and maintaining your own expensive computer servers in a closet somewhere, you just rent access to a massive, shared pool of computing power over the internet from a big provider like Amazon, Microsoft, or Google.
And what makes the cloud so revolutionary are these key traits. First, it's shared infrastructure, which makes it way cheaper for everyone. You get on-demand access from literally anywhere you have an internet connection. And maybe most importantly, you can fire up new servers or storage in minutes with just a few clicks, a process that used to take weeks of buying and setting up physical hardware.
Now, cloud services usually come in three main flavors, or layers. At the very bottom, you have Infrastructure as a Service, or IaaS. That's where you're just renting the basic building blocks, the servers, the storage. A step up is Platform as a Service, or PaaS. Think of this like a fully equipped workshop where you can build your own applications. And at the very top is Software as a Service, or SaaS. That's the finished product, like Gmail or Netflix, where you just use the app and don't worry about anything behind the scenes. But look, moving to the cloud is all about trade-offs. On one hand, you get amazing benefits like lower costs, flexible pay-as-you-go pricing, and the ability to scale up instantly. But on the other hand, you're giving up some control. That can create new complexities, introduce security and privacy concerns, and of course, it means you're pretty dependent on your cloud provider. And its whole evolution has led us to things like SQL data services. This is really where the power of a traditional, reliable database meets the incredible flexibility of the cloud. It's a service that gives you a full-blown database that lives in the cloud, which means even a small startup can build powerful apps without having to spend a fortune on their own IT gear. It's basically the modern global-scale solution to that very first problem we talked about, connecting an app to a database. So we've gone from these simple APIs to solving the web's memory problem, and now all the way to these massive global cloud databases. The way we connect to our data is just constantly changing. It really makes you wonder, right? With everything from our phones to our refrigerators now online, what's going to be the next great connection challenge that we'll have to solve?